Section 8.2, in our video notes, we're going to be looking at graphing some radical equations. And the radical equation that we're going to begin with is the square root of x. So we're going to find some values here, plug them in, and evaluate them. So 0, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. Okay, just making a note, we chose those x values specifically because they were perfect squares and they were going to be easy to evaluate. So something you want to keep in mind when you're working with radical graphing. So I have 0, 0, 1, 1. Also keep in mind that the scale on this is stretched, so that the x scale is much shorter than the y scale, so this function is going to look taller than it really is if you had a 1-to-1 scale. And then 9, 3. 16, 4, 25, 5, and 36, 6. Okay, now I could definitely keep going and add 49 and so on, so I'm definitely going to be able to keep going on the right-hand side of this. But if I go back, normally we plug in some positives and some negatives, but if I plug in a negative, the square root of -1, it has a value, I, but it's not real. And if it's not real, I can't graph it on a number line. So I can't plug in the negatives for x. And so my graph stops at 0. And instead of continuing in both directions, it has an end point. Now, if you have any transformations, like it's not just the square root of x, but maybe the square root of x minus 2 or some other function, it might not be at 0, 0, but all radical functions are going to have an endpoint. All square root graphs, I should clarify, are going to have an endpoint. And that endpoint will affect your domain and your range. Okay, so we'll just draw a big arrow down there for domain and range. The domain of this one, okay, this one has a lowest x value of 0, and it's heading all the way over to infinity. So 0 gets to be included, comma, infinity, excluded if infinity is an idea. And then for its range, it's still 0 as a lowest and infinity as a highest. So they are both bracket 0, comma, infinity. Now that's the interval notation. We can use inequality notation here as well. So the inequality notation would be x greater or equal to 0 for the domain and y greater or equal to 0 for the range. Okay. The graph of this has a special point called the end point, which in this case was 0, 0. Important to note that you don't draw your graphs to go through those because they truly do not.